All right, so to use the second derivative test to find the relative extrema of our next one, again, we're going to need to find the first and the second derivative. So if f of x is negative 2 times cosine x minus x, then the derivative will be positive 2 sine x minus 1. And we need to know where that derivative is equal to 0. Again, notice that in this problem there are no places where the derivative would be undefined, since sine of x is defined for every value between 0 and 2 pi. So if this is true, then we know that 2 times sine of x is equal to 1, which means sine of x would be equal to 1/2. And so we're looking for the angles between 0 and 2 pi such that sine would be equal to 1/2. And we know that sine is equal to 1/2 at pi over 6. And again, in the second quadrant, at 5 pi over 6. So now we need to check the second derivative at each of these values. So the second derivative of f will be the derivative of 2 sine of x, which is 2 cosine of x, minus the derivative of 1 is 0. So the second derivative at pi over 6 is 2 times cosine of pi over 6. And again, we don't necessarily have to have the exact value. We just need to know if it's positive or negative. In this case, though, it's pretty easy to find the exact value. Cosine of pi over 6 is positive, so we're going to get a positive value. Specifically, we get positive square root of 3. So, since the second derivative at pi over 6 is greater than 0, and the first derivative is equal to 0, we know that we have a horizontal tangent line. The graph is concave up, so this point is a relative minimum. And our x value is pi over 6. Our function value would be 2 times cosine of pi over 6, negative 2 times cosine of pi over 6, which would be negative square root of 3. We've already calculated that part. Minus pi over 6, plugging back into our original function. Now we want to look at 5 pi over 6. At 5 pi over 6, we have 2 times cosine of 5 pi over 6, which will be 2 times negative square root of 3 over 2, or negative square root of 3. So this time, we know that the second derivative at 5 pi over 6 is negative. It's less than 0. So we know that we have a horizontal tangent line, and our graph is going to be concave down. So there is a relative max. Where x is 5 pi over 6. And if we plug 5 pi over 6 back into our original function, we have cosine of 5 pi over 6 times negative 2, which this time will give us a positive square root of 3, minus x is 5 pi over 6. So we have a minimum at pi over 6 and a maximum at 5 pi over 6. Now you may be wondering, if we have the first derivative test, and the first derivative test can tell us whether or not we have an extrema, why would we need a second test? Well, there's lots of different applications for the second derivative test, and there are lots of different ways that they can word questions on the AP exam that are going to force you to use the second derivative test. And that's what's happening in this last example. So here they've given us that the derivative of f of x is equal to g of x times x squared minus x minus 6. We know that g of 3 is negative 2 and g prime of 3 is 7. And they've asked us to determine whether f has a relative maximum, a relative minimum, or neither at x equals 3. So the first thing we need to know is, what is the derivative of f at 3? Well, if we substitute 3 in for x, we see that the derivative will be g of 3 times 3 squared, 9, minus 3, minus 6. Well, g of 3 is negative 2 times 9 minus 3 minus 6 is 0, gives us 0. So we've got a critical number at 3, which means we may possibly have a maximum or a minimum. So if we can determine the sign of the second derivative, we'll be able to determine whether or not it is, in fact, a maximum or a minimum. So if f of x is equal to g of x times x squared minus x minus 6, then the second derivative of f will be the derivative of the first derivative. And to find this derivative, we're going to have to apply the product rule. So we have our first function, g of x, times the derivative of the second function. The derivative of x squared minus x minus 6 will be 2x minus 1. Plus our second function, x squared minus x minus 6, times the derivative of the first, and the derivative of g of x is g prime of x. So now I need to know, what is the sign of the second derivative at 3? So if I plug that in, I've got g of 3 times 2 times 3 would be 6 minus 1 is 5, plus, we've already substituted 3 in here. We already know that that's going to be 0. If I plug in 3 for x, this is 0, times g prime of 3. Well, g of 3 is negative 2. So I have negative 2 times 5 plus 0 times g prime of 3. Well, g prime of 3 is 7, but that really doesn't matter because when we multiply it by 0, we get 0. So I have negative 2 times 5 plus 0 gives me negative 10. So if I put that together, since f prime of 3 equals 0, and the second derivative at 3 is negative, is less than 0, we know we have a horizontal tangent line and that our graph is concave down. So that tells us that we must have a relative maximum. At x equals 3. And in this problem, that's the only way we could come to that conclusion, is applying that second derivative test, because we don't know what the sign of the first derivative looks like on either side of 3. But we do know that the second derivative is negative. So again, we know we have a horizontal tangent line at 3, and we know the graph must be concave down. And so the only way that we could have that combination of events is if that point is a relative maximum.